Penel Educates. In this mathematics series, we'll be looking at number bases, and I'm expecting that at the end of this mathematics series, you should be able to convert numbers from order bases to base 10. You should be able to convert decimal fractions from order bases to base 10. We'll also be looking at how to convert numbers from one base to another base. I will be performing some operations on number bases like addition, subtraction, and multiplication. I'll also be looking at divisions of numbers. And lastly, we'll look at applications of number base to computer programming. So we'll start with denary. Denary or decimal scales, they are called base 10. They are numbers in base 10. And this denary or decimal base has been accepted by the international community. People now count in groups of tens. They make use of digits from 0 to, they make sure digits from 0 to 9. And all these numbers, they are the numbers, 0, 1 to 9, they are the numbers that you find in all the numbers that you can get. So these are the digits that you find in all numbers. And we now use the concept of place values to represent any number whatsoever. So, for example, if you are given this 2574, we use the concept of place value to represent it. In an expanded form, 2574 can be written like this: 2000 plus 500 plus 70 plus 4. So it means you can have like 2 times 1000, 5 times 100, that is the 100th position, that is 7 times 10, which is tens, and 4 times 1, which is ones, that's the unit. So the indices that we have here, which are the times 10 raised to the power 3 and all those ones. So if you have a number like 2574, which is being done, now you can write some indices on it starting from this, like 0, 1, 2, 3. Okay, so that's why you have 2 times 10 raised to the power 3 with this. Okay, because these are in base 10. Then 5 times 10 raised to the power 2, which is this. Then plus 7 times 10 raised to the power 1. Then 4 times 10 raised to the power 0, which gives this. So if you add all this together, everything will be 2574. But if you have other numbers, say you have 257.321, right? So if you count from here 0, 1, 2, the numbers that are after decimal points, you start using -1, -2, -3, all like that. So that's how to indicate the indices on the numbers. All right. So as you know, the indices that represent 0, represent the units or one place value. So the one that is 1 represent tens, like I said, and the one that is 2 represent hundreds, and the one that is 3 represent thousand. All right, so it means that the powers 10 raised to the power 3, 10 raised to the power 2, 10 raised to the power 1, and 10 raised to the power 0 shows the place value of the digits. All this shows the place value of the digits. All right, so we can be told to expand numbers. So this is how to do our expansion if at all such question is asked. All right, so let us look at conversion from order bases to base 10. How do we convert from order bases to base 10? All right, so this that you see here, 25 raised to power, 25 base n to base 10. All right, so 25 base n to base 10, that is what we are doing. And what do we need to do to start? We need to start putting our indices. That's 0, 1. Right. So how do we go about that? So we'll multiply these two, pick these two, multiply by this n, which is the base, raised to power 1, then plus this 5, okay, multiply by n, which is the base, all right, raised to power 0, that is there. All right, so this is how we can convert it. So when we do our addition, then we get a number which is then in base 10. So let's take, for example, we're given 537 base 8 and we're to convert to base 10. So we start do our numbering 0, 1, 2. All right, so we'll go 5 times 8 raised to power 2, okay, plus 3 times 8 raised to power 1, plus 7 times 8 raised to power 0. All right, so when we do all these calculations, 64 multiplied by 5, 320, 3 times 8, 24 plus 7. So you have 351 base 10. So 537 to base 8, that's 351 to base 10. Now, let me tell you something here when you are looking at the bases. Okay, for example, if you have numbers like 2, 3, 7, you cannot have this as base 7. You cannot have it as base 3. You cannot have it as base 2. Right. All the digits here must be less than the base. Okay, let me write that. All digits of a given number, okay, must be less than, all right, the base. Okay, so that's why when we have numbers in base 10, you can have 9, 3, 1. So this is the highest number that you can have in base 10. All right, so all these numbers, all these digits that are here, they must be less than the base. For example, if you have base 2, so you can only have 0, 1, 1. You can only have 0 and 1 for base 2. Okay, then for base 3, you can only have 1 and 2 and 0. In base 3, you cannot have any number that is the same number with the base or higher than the base. You cannot have that. Right? For example, you cannot have 2, 3, 8 as base 8. Okay, you cannot even have 2, 3, 9 as base 8. So the digits here for the base that you're talking about must be less than the base itself. So that is um, uh, the logic behind how you can recognize which base the digit that you are given is. All right, so we'll look at how we can convert from other base to base 10. We just look at conversion of base 8 to base 10. So let us look at the other methods that we can use to convert from other base to base 10. And this method, we call it repeated or successive multiplication. So what do we do when we are given 263 base 8 and we're to convert to base 10? So what do we need to do? What we need to do is to, okay, for example, this 2238 base 8. So what we need to do is to look at the base, right? So we take this particular number. So we look at the base, we put base 8, multiply by this number, that's 2. Okay, it's going to give us 16. Then we add the result of 16. We add it to the second number, which is plus 6. That's 22. Then we multiply the results after that with 8, and that will give 176. Then we add the last number to it, plus 3, which will give 179. That's base 10. right? So if you do it the other way that I just taught you now, choose 10, that's you do 263 base 8, you want to convert to base 10, you do 0, 0, 1, 2, then you do 2 times 8 raised to power 2 plus 6 times 8 raised to power 1, that's plus 3 times 8 raised to power 0. Alright, so you get this as 128, then plus 48 plus 3. Alright, so this is also 179 base 10. So, but you can do repeated multiplication like this. So you take the base that is involved, you multiply it by the first digit, then you get your result 16, then you add it to the second one. So that means we multiply, we add, right? Then we multiply with the base again, then we now add again. So that is how what we can do to convert that. All right, so let us look at how we can convert decimal fraction in any base to base 10. For example, we are given 6.4 base 7, 6.4 base 7. Don't forget, irrespective of how the digits are placed, irrespective of maybe it has the numbers as a decimal number, don't still forget that any digits that are here must be less than the base that you are given. To make that base correct, it must be less than. Okay, so here, like I discussed before now, we just put anything after decimal towards your right, you put -1. Then from here, you do 0, 1, 2, depends. Okay, so we have 6 times 7 raised to power 0 plus 4 times 7 raised to power -1. And you know that 7 raised to power -1 is 1/7. So when you do all these calculations, you get 6.5.7. Okay, so that's how that one is. So let us look at other ones. For example, when you want to convert this type to base 10, which is also having a decimal point. Okay, so now what do we do? Before we said notice 11011.1001. So how do we place our indices? Don't forget here towards your left you do 0, 1, 2, 3, 4, and towards here you do -1, -2, do -3 and -4. So let's take this part first. This one. Let's take this one first. So that's what we've done here. So we do our 1 times 2 raised to power 4. This is in base 2. Okay. 1 times 2 raised to power 4. Then this particular one times 2 raised to power 3. Then 0 times 2 raised to power 2. 1 times 2 raised to power 1. Then 1 times 2 raised to power 0. So if you add that one together, you get this, which is 27.10. So now if you do it for the other side, which is -1, -2, -3, so what you don't need to do is just take this one, that's 1 times 2 raised to power -1, that's the place value, then 0 times 2 raised to power -2, 0 times 2 raised to power -3, and 1 times 2 raised to power -4. All the one that is 0 times, all these, they are actually 0. So half plus 1/16 will give you 9/16, which is this. So if you just want to find your answer, you just need to add this, with this. Okay, so when you add it together, you get your answer in base 10. So basically, that's how we convert numbers. That is numbers that are having decimal points, or that are having decimal points, or numbers are just like fractions. That's how we can convert it to base 10. All right, so let us also look at how we can convert numbers from base 10 to other bases. Okay, for us to do this, if you are to, let me just give you the law behind this. So if you are to convert any number in base 10, you have to convert any number in base 10 to another basis, maybe base n. All right, so you're going to use this base to divide the number. All right, so what we're saying is that if you have to convert any number from base, say base 10, 453 to base 10, we have to convert it to uh, base 6. So what I need to do is to put the 4532 here, then I will use 6 to divide it. All right, constantly divide it by 6, I'll get the remainder. Constantly divide by 6, so then whatever I get will be my answer in base 6. Alright, the same thing happens if I'm to convert this in base 10 to base 5. I'm going to use 5 here rather to divide the number. Alright, so that is how to convert from base 10 to other bases. So if you look at the example that we're given here, so we constantly divide 207 by 2. Alright, so if you divide 207 by 2, you get 103 remainder 1. And all that. That's how you do all that up till when you get 1 remainder 1. When you see that the numbers can no longer be, you can no longer divide it by 2, so 1 remainder 1. So then you do your counting, you do your writing of the answer from here, up to the top. So we have 1 1 1 0 0. Then 1 2 3 4, that is 4 ones. Okay, base 2. So that's our answer of converting 207 base 10 to binary. So if I have to convert the same thing to octal, so what do we need to do? 8 divided by this. So octal is 8. Octal is in base 8. Hexadecimal is in base 16. Alright, so we have 8 octal divided by this 25, that's remainder 7. Then we have 3. 8 can no longer divide 3. So we have 317 base 8. So let us look at how we can do the conversion using the same number. If we are to convert to hexadecimal, I told you hexadecimal is 16. Alright, so 207, 16 in 207 is 12, and you have remainder 11. Now 12, 16 can no longer divide this, so then we'll stop. So that means we have 12 and 11. So we have 12 and 11. And for hexadecimal, which is base 16, that is something that you should know. Hexadecimal is written like this. We have number from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So when you get to number 10, instead of writing 10, you represent it by A. Okay, 11 divided by B. 12, you represent it by C. 13, you represent it by D. 14, you represent it by E. And 15, you represent it by F. So that is how hexadecimal is. Right, so it's from A to F instead of writing 10 and 11. So for this particular one now, we have 12 and 11. So 12 represents 6 here, 12 represents C here, so we put C here. Then 11 represents B. Alright, so instead of writing 12 and 11 here, 12, 11, we have C and B base 16. So that is how to convert numbers from base 10 to hexadecimal. That is another base. So that is how to do that. So if we now need to convert number from one base to another, the one of the best ways to do that is to just convert. So if you had to convert base 2 to base 8, for example, so what you just need to do is to convert the base 2 to base 10. You already been taught this, you know that already. Then the second one is that after you've gotten the answer, all right, so convert the answer, which is the result, to base 8, right? So you first convert base 2 to base 10, then your result from base 10 you convert to base 8. So that's how you can convert numbers from base 2 to base 8, right? So now let us look at some applications of uh, binary numbers. So if you look at some application of binary numbers, you know that binary numbers has only 0 and 1 digits. They only have 0 and 1 digits, and the computer operation, this can actually be used for computer operations because we can use on and off, which also uh, translates to on is 1 and off can be 0. All right. So, for example, if we have the following questions, this following question can be that, okay, have you eaten? Okay, yes, I've eaten. That's one. Is 59 equal to 20 times 5 which are 2, in indices? All right. So we have yes, 1. Okay, is sine 45 degree is equal to half 1 over root 2? Yes, 1 over root 2. Are you attending the party? Then you said 1 for no. Okay, so and all the alphabet that we have can also be coded. All the alphabet can also be coded. We have um, the alphabet A is 0001, alphabet B is 0010. You know that all the alphabets they are actually from 1 to 26. So you have your A, B, C. So all this one and all these numbers which are decimal, you can convert them to binary, and that's what we've done. So if I'm to code the word stop, okay, for example, I know that S, the position of S in the alphabet table, the position of S is 19. Okay, so now if you convert 19 to binary, 19 to binary is give you 10011. All right, so I have 1001 as okay as this S. So what about T? T is just next to it, which is 20. All right, on the alphabet table, on the alphabet. Then we have 20 to be, if you convert it to binary, so that's 10100. That's the. Then I have 10100. That is for the S. Okay. Then for O position O is just 15. Position O is 15, and if you convert 15 to binary, 15 to binary is actually 0, 1, 2, 3, 4. Okay, right. So I can have 0, 1, 2, 3, 4. Okay, then P is just a 16 position, on the alphabet. Then we can have 16 being converted to binary. 15 is like 1, 1, 2, 3, 4. All right. So I can have 1, 1, 2, 3, 4. All right. So now I've been able to convert the word stop into a code. Okay. So all these things that you see, the 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 stop is actually expressed in equivalent codes. They actually expressed in equivalent codes. And don't forget that those numbers that you see here, they are decimal numbers, they are numerals. Okay, so they are decimal numbers. So all messages can be coded, and like this. So that's how we apply it to uh, computer programming. Okay, so let's look at how we can convert binary to octal and also binary to hexadecimal. Don't forget that is like converting from one base to another base. Okay, so but let us look at the other ways that we can do that. So let's convert 10610, okay, to octal and also to hexadecimal. So now the octal is base 8, so which also means 2 raised to power 3. So we can group the binary numbers that we have, we can group them in threes. That's what it means. So if 106, if you convert 106 to base 2, that's the binary, this is what's going to give you. So this is the binary that we're looking forward to convert to octal. So once you group them in 3 from here, 0, 1, 0, this is group 1. Okay, this one group. Okay, then we have 101. Okay, that's another group. Then this one can also be like 001. Okay, this is the last one. Okay, so this particular one is 1. Okay, already. So if you look at it, this one, um, that is in decimal, then it's 5. This one also decimal is 2. So you can have 152 base 8. That is how to convert this binary to octal. Another way that I can look at it is just to convert this binary. I will convert it to base 10, everything together to base 10. Then from base 10, I will now convert to base 8. Okay, so now if you look at the same thing for hexadecimal, just looking at the same binary, because hexadecimal is base 16, that's like 2 raised to power 4. So we're going to group in 4. So this same number that we're given above, that is 1 1 0 1 0 1 0. All right, so we're going to group in 4. So if you have to group this in 4, okay, so what do we have? This is the first one, first grouping, and this is the second grouping. Okay, so this one you can even have 0 to it. There's no problem about that. Okay, so now this 110, if you convert it to decimal, this is 6. All right, so if you look at this particular one converted, this is 10. And don't forget, 10 represents A. Don't forget I have 0, 1, 2, up to 9, the other one. So 10 represents A. So instead of writing 10, we put A. All right, so here we have 6A as our conversion. All right, so that's how to convert binary to octal or hexadecimal. So if you have binary that you want to convert to octal, for octal just group in 3. Then for hexadecimal, just group in 4, and you get and you convert each of the grouping to decimal, which is base 10. Then you get your number. Okay. All right. So let us look at conversion from octal now. So you want to convert from octal or want to convert from hexadecimal to binary. All right. So now if we're given this number 615 base 8, and we are to convert to denary, which is base 10. All right, so because this is base 8 and we're converting to base 10, what do we need to do? Now we know that we have 615 is 8, so we can take the digits, the number one by one. So what do I need to do? I'll take this 6. Okay, I'll take this 6 first, bring it here, convert it to binary to give me this. All right, I will take this particular one. It's already in binary, so I will not bother about it. So I will take this 5, which is not in binary. I'll convert that 5 to binary, and which is 111. So if I look at my answer, I'll just put everything together. This is 110. This one is 001 because it's just 1. Yeah, so you can put it because you're actually grouping in 3s. Why are we grouping 3s? Because of being octal. Okay, so if you're octal, which is 2 raised to power 3, you group with 3. So when you have all this come together, you put everything together. This now give you your number in base 2. That is in binary. So what have we done? Converted 615 in base 8 to binary. Okay. So, and the first method that I said, this is actually converting from base 8 to base 10. What you can do also, if you don't want to go that route, is to convert this base 8, convert it to base 10. Then from base 10, you now convert your answer to binary. That is converting numbers from one base to another base. So what do we need to do? Convert base 8 to base 10. Then from base 10, you can then convert to binary. That's another method of doing that. All right, so if you also look at how we can convert from hexadecimal to binary. So what you just check is how to convert from octal to binary. So this particular one we'll be looking at how to convert from hexadecimal to binary. Okay, so if we are to do this, so we'll take the numbers one by one. So we take one, this particular one, take one. Okay, so we'll put it here. So we convert it to binary. That's 001. 4 to binary is this. And don't forget B in hexadecimal, A is 10, B is 11. So if you convert 11 to binary, is going to give me this. Then you convert 2 to binary, is going to give you this. So, and why are we doing that? Because it's hexadecimal, which is base 16, and that's 2 raised to the power 4. So we're going to group, in fours, and that's why we're grouping in fours like this. Grouping like this in fours. So if you put everything together, you're going to get this as base 2 in binary. So that's how to convert hexadecimal to binary. We did previously on how to convert octal to binary. So if they're giving base 8, just pick the number one by one, convert to binary, then change it. Just convert to binary. Then after you are done, then I put everything together. For octal, you group in threes. For hexadecimal, you group in fours. All right. So now, if we don't want to do that, because we are converting from hexadecimal to binary, that means we are converting from one base to another base. So what do we need to do? Convert this to base 10, then the result, convert it to binary. That's as simple as that. So what we'll do here is that 4B2, convert it to base 10, then after the answer, then now convert this 592 to base 10 to binary, and that's how we now got this particular one. So if you compare the answer, they are actually the same. All right, so let us look at operation with bases. Let us just look at addition and subtraction. But before then, I want us to take a look at normal addition that we do using the decimal. We know how normal decimal addition and normal decimal subtraction. So let me just do that first. Right. So if I have 25 plus let's say 78. Okay. So normal addition, you do 8 plus 5. All right. Set 13. You write 3 here. You carry 1. Let me actually tell you what happened there. This is base 10. This is base 10. All right. So 8 plus 5 is 13. And because it's base 10, what do we need to do? We divide that 13 because it's higher. That 13 is higher than 10. Okay, the addition of this is higher than the base, right? So, and we know that the base is 10 and our answer is 13. So what do? We divide by 10. So 10 here we have 1, then remainder 3. All right, so we put this remainder 3, this particular one, then we put it here. Okay, then we carry 1. Okay, so when we have 7 plus 2, 9, plus 1, that is 10. The 10 that we have gotten here is the same thing as this 10, and any number in base in any base must be lower than that base. So 7 plus 2 plus 1, that is 10. Then we cannot write 10. Then what do? We do 10 divided by 10. So this particular one means 1 remainder 0. Okay, so we write remainder 0, then we carry the 1. So that's how this addition is being done. 103. So, but we are used to 8 plus 5, 13, you carry 1, 7 plus 2, 9, that's 1 plus 10, then we put our 10 in. But that's the way, the way it is actually being done. So, we can also do the same thing with subtraction. Let me also show you subtraction, of numbers, that is using the decimal. So we can have maybe 79 and let me say 76. All right, so I'm to subtract 28. So what do we do here in subtraction in decimal? Okay, we said 8 from 6 is not possible. All right, so when we borrow 1 from here, because all these they are actually in base 10, when we borrow 1 here, it becomes 10. All right, so when we add that 10 to 6, it becomes 16. All right, so we now remove that, remove 8 from 16. So 16 minus 8 will give you 8. This particular one is remaining 6 already. So when we take 2 from 6, then we have 4. Okay, now this mathematics that we've known, is the same thing that happens to all other bases. Is the same way. We do the subtraction, we do the addition same way. For example, 3 plus 2, these are in base 8. 3 plus 2 is 5, so we write 5 because it's not up to 8 and it's not more than 8. So 7 plus 4 is 11. Alright, so this 11 is more than base 8. All these are actually in base 8. So 7 plus 4 is 11. Alright, so then we divide by the base, which is 8. Alright, so we get 1 remainder 3. Okay, so we'll put our 3 here. Then we carry 1. Alright, so when we had 6 plus 1, it will be 7. And 7 is not equal or more than 8. So that's how we get our answer. The same thing happens with subtraction. 3 in 1 is not possible. All these are in base 4. All these are in base 4. Okay, so if 3 in 1 is not possible, then we'll borrow 1 from here. Don't forget the place value of these are 4 is to power 0, 4 is to power 1, 4 is to power 2, 4 is to power 3. Okay, now borrow 1 from here. Once you borrow 1 from here, it becomes, when it gets there, it becomes 4. Then we add it to this, then it becomes 5. Alright, so 5 minus 3 will give you 2. Okay, alright, so here we have 0 already. So 0 minus 1, if you take 1 from 0, it's not possible. So you borrow 1 in again, it becomes 4 when it gets here. So add 4 to 0, that's 4. Then 4 minus 1 to give you 3. That's how we get 3 here. Then don't forget this one already is 2. So 2 minus 2 is 0. Okay, and that's the 0 that is there. Then this is already remaining is just 2. So 0 from 2 is 2. So that's how we arrive at our 2. It's just the same way. It's just the same way. So if you do multiplication also and it's more than that, let me just quickly look at a multiplication that we can do. Let's say we have 24 in base 5, and now to multiply it with 33. Okay, so let's do the multiplication. 3 times 4 is 12. Okay, it's more than base 5. Okay, so I do division by 5. So I have my 2 remainder 2. Okay, so I put my remainder, I put it here. I put my remainder here, which is 2. Then I carry my 2. Okay, then 3 times 2, that is 6 plus 2, that is 8. 8 is more than base 5. So I do my 8 divided by 5. What am I going to get? That is 1 remainder 3. So I put my remainder 3 here, then I put my 1 here. Alright, so I go with this again. 3 times 4, that is 12. Okay, which is also more than, so it's just the same way. I do the same thing the same way. If I do the same thing the same way, I'm going to get my 3 times 4, that is 12. Divided by 5, I'm going to get 2 remainder 2. So I'm going to put my 2 here. Okay, it's also remainder 2. 3 times 2, 6 plus 2, that is 8. I do my 8, the same thing. I'm going to have my 3 and my 1. So if I add this together, okay, right? So if I add this together, that is 1, 3, 2, and I have another 1, 3, okay, 1, 3, 2. Okay, so if I'm to add that, okay, let me just quickly do some cleaning up there. Alright, so if I'm to add that, don't forget I will also be adding in base 5. Okay, so I'm to add that, after my multiplication, I'm going to do 2 plus 0 to 2, 3 plus 2 is 5, then it's not supposed to be, because it can't be, any addition cannot be with the same base, I mean equal to the base or higher. So I have 5, so I'm going to do my 5 divided by 5, that is a 1 remainder 0. I put my 0 here, okay, and I carry my 1. So 1 plus 1, that's 2 plus 3, 5, that's another one. 5 is going to give me 1 remainder 0 again, so I put my 0 here, then I carry my 1. Okay, so 1 plus 1 is going to give me 2. All right, so this multiplication 24 by 33 in base 5 is actually 2002. All right, so that is how the multiplication is being done. All right, so that's the same way it's being done, which is also explained here. 2 times 1 is 2, right? 2 times 2 is 4, because 2 times 2 is 4 and it's more than the base 3, so I divide by 3, it's going to give me 1 remainder 1. I put my 1 here, good, then I carry 1, okay, so my 2 times 1 is 2 plus 1, that's 3, it's 3 cannot, so you do your 3 divided by 3, then it's going to give me 1 remainder 0. I put my remainder 0 here and I put my 1 here. Okay, so that's how to look at that. So let us look at the division. Let's quickly look at the division. All right, so one of the ways we can use to do this, so if we are to divide 204 base 5 divided by 3 base 5, you can convert this. You can convert this to base 10, convert this to base 10, do your division. You can also do it in the multiplication. Convert each number to base 10, do your multiplication. By the time you get your answer, convert it to that base again. So you can convert it to base 10, convert it to base 10, do our division, then the answer will convert it to base 5 back. All right, so that's how to go about that. But the one that I want to do now is how to do the division directly. How to do the division directly. Okay, so how do we go about that division? Okay, so I want you to watch this very carefully. All right, so the traditional way of doing this division is to divide the 2 by 3. So, and since this 2 is less than 3, then we convert this 2 base 5. Okay, so what do we do? 2 is less than 3, so 3 cannot divide 2, right? So this 2 base 5, this 2 here, this 2 here, all right, this 2 here, all right, so we convert it. What do? We said 2 multiplied by 5, using base 5, is going to give us 10. Okay, now we now add this 10 to the next 0. Okay, you remember the repeated things that I said the other time. Okay, so but this one we're going to be doing division. So this 10 plus 0 is going to give us 10, right? So the other time we are multiplying again, but this time around we're going to divide this by 3. This 3 here. Okay, this 3 here, right? This particular one. We're going to divide it by 3. So we have put the 3 here. So once you do that, it's going to give you 3 remainder 1. Okay, so it's going to give us 3 remainder 1. That's what it's going to give us, 3 remainder 1. So what do we do to this 3 remainder 1? We add, this is the way, it's 204. Okay, 3. So we put the 3 here. Okay, is remainder 1. So this remainder 1 that is here, we put this one, that is this remainder 1, we multiply it again by the base, that is times 5. Then our answer is 5. Then we add it to this 4 again, plus 4, so which is 9. Then we divide by 3 again. Okay, so if you divide by 3, we're going to have 3 remainder 0. So this 3, we put it here. All right, the remainder is 0. Then there's nothing we can do about it again. Let me say it again. You want to divide 204, by 3. all in base 5. You pick these two. These two cannot, 3 cannot divide these two, right? So we'll take these two, we multiply it by that particular base, which is 5. 10 times 2 times 5 is 10. We add it to the next digit, that's plus 0. Then we do our division. 3 remainder 1. We put that 3 here, 3 can go there. Then it's remaining 1, that's remainder 1. So we take this remainder 1 again, multiply by 5, which is this particular base. Then it's going to give us 5. Then we'll add it to the next digit, plus 4. That is 9. Before we can now divide it by 3 again. So once we divide by 3, it's going to give us 3 remainder 0. That is 3. Yeah, that's why this is actually 33. So that is the way division and multiplication supposed to be. Now let me show you some other divisions that we can do. For example, if we are given 3, 3, 4, okay, let's say which base do I want this done? Let's say I have 3, 3, 4 in base 6, okay, divided by 2 in base, let's say, okay, let me just put this in base 5. Alright, let's just say base 5, and this one is base 5. Okay, good. Alright, so what do we need to do? So go the same way. 3, 3, 4. Okay, this is in base okay, we want to use 2 to divide it. Alright, everything is in base 5. So everything is in base 5. So we are using 2 to divide it. Okay, so what do we do? Now, this particular one, 3, 2 can go in 3. Alright, so if you use 3 to divide 2, so you're going to give you 1 remainder 1. Okay, so then we put our 1 here, we carry the remainder. The remainder is 1. Then the remainder that is 1, we multiply it by 5. Don't forget the base 5. Divide by 5. Alright, so which is 5. Then we're going to add it to the second number, that is plus 3. Okay, then it's going to give you 8. Alright, so if you do this 8, then you then divide by 5, which is the base. Alright, so this is going to give you 1 divided by 2. Okay, not by 5. You know, we're actually dividing by 2, and this is the 2 that is there, so we'll divide it by 2 rather. This is the 2 that is there, 2. So it's going to give you 4 remainder 0. So I just need to take this 4, I put it here. Alright, so I have remainder 0, so I'm going to take the remainder 0, then multiply it by my base again, which is this 5, multiply by 5. Okay, and that is I'm going to now add it to this particular 4. Right, this particular digit. So 0 times 5, that is 0, then plus 4, and that is 4. Alright, so if I divide this 4 by these 2, right, it's going to give me 2 remainder 0. Alright, so this 2 is what I need to put here, and the remainder is 0. You know, so my answer is 142 base base 5. So the division is 142 by base 5. So if I don't want to do that, I can just convert this. I can convert this to base 10, convert this to base 10, do my division, then get my result, and then convert back to base. I can convert back to base 5. Okay, so that's just all about the number base. Right, so well, in summary, let me just in summary, we've looked at octa, we look at binary, all right, we look at octa, we looked at denary, which is decimal on base 10, we look at hexadecimal. And one of the things that I discussed with you is that if you want to convert numbers from any base to base 10, we simply express the number in its expanded form. Put all the indices, all the expanded form. That's what we just need to do. We express it in the expanded form and simplify. Or we can do we multiply and add up successively. That is the repeated multiplication that I did during that time. All right. So also, if you want to convert from base 10 to any other base, I said you just need to divide successively with the number. You divide that number by the base that you want to convert it to. That's converting base 10 to other bases until the quotient is 0, and you write out the remainders from the last to the first. Like I said, you just do like this, put the number here, you divide it, then the last number that is here, write it from the bottom, to the top, and that's how to do that. I also told you that if you want to convert from one base to another base, which is other than base 10, you can first convert, if you want to convert from base 2 to base 4, you can first convert this base 2 to base 10, then the result, you can then convert it to base 4, and that's how to do that. Alright, so we also discussed that in computer programming, the number-based system, especially base 2, is applied. So where 0 and 1 translate to mean off and on, or we can say the 0 can be no, or the 1 can be yes. And we also look at operations, addition, subtraction, multiplication, on how to perform that. Okay, so let me just quickly look at probably look at one example before we end this video. All right. Okay, so let's quickly look at this example. We are told we're given 53 base y plus 62 base y equal to 125 base y. What is the value of y? So how do we go about this? So just put our 0, that's our indices, so on all of them, 0, 1, this particular is 0, 1, this one 0, 1, 2. So if you do that, 5 times y raised to power 1 plus 3 times y raised to power 0 plus 6 times y raised to power 1 plus 2 times y raised to power 0. Do it for the same thing as 1 times y raised to power 2 plus 2 times y raised to power 1 plus 5 times y raised to power 0. So if you do that, this one will be 5y, this will be 3, but this is 1, and this will be 6y. So if we do that, we have 11y plus 5. This one we have y squared plus 2y, which is equal to plus 5. So if you have y squared plus 2y minus 11y plus 5 minus 5, take it to the other side, you're going to have this, will actually be 0. Then you're going to have y squared minus 9y, which is 0. So if you try to expand that, to have y into y minus 9. So y can either be 0 or 9. And we know that y cannot actually be 0 because, you can't have be 0. So you can only have 9. So that means our y, is equal to 9. All right. So that is the end of our video series on number basis. I want you to subscribe to our video on Pen and Educate, and let us have feedback from you if there are issues in solving problems. And we know that one email address will be shown at the end of this video, so please send your comment. I want to hear from you. All right, I hope this has been very informative for you. Have a wonderful time solving problems in number basis. All right, see you in another video. Bye.